Hello Legacy Savers. Today we're going to look at scatter plots and trend lines. What you're going to want to have on you today, your notes, all those papers I gave you in class, a pen or pencil, and then you also may need a calculator today. Your learning goals. I can identify the type of correlation a scatter plot shows. You can plot a scatter plot. I can find the equation of a trend line, and then you can also tell the difference between correlation and causation. First, we need to do some vocabulary. The first thing you need to know about is a scatter plot. So a scatter plot is basically a graph that's created by graphing a table of values that relates to quantities. So basically, it's a bunch of dots made from a table you have. A trend line is a linear function drawn in a scatter plot to show the general direction of the data. So basically to show if the data looks like it's mostly going up or going down. A correlation means there's a connection between the two quantities that are graphed. Basically, they're both going up or they're both going down. Causation means when one quantity causes the other variable. Causes the other variable to change. Gotta make sure we change that to change. There we go. So different kinds of correlation. When y increases and x increases as well, this means your data has a positive correlation. Notice if I draw a line in here, it's going to mostly go up, right? So that's a positive correlation because it has a positive slope. When y decreases and x increases, that means that the data has a negative correlation. So basically it looks like they're going downwards. When x and y are not related at all, that is called no correlation present. So here, let's make a scatter plot on this data that we have. This table shows the altitude of an airplane and the temperature outside the plane. We need to make a scatter plot and then determine what kind of correlation. So it looks like I'm talking about altitudes and temperatures. So altitude's going to go down here, and temperature's going to go up here. There we go. Now I need to do my list here. So the x's looks like they're going by 500ths. So what I'm going to go is I'm going to do every other, 500, and this would be 550. No, hold on. 500, and then it'll be 1,000. Then I'm going to go skip one. I'm going to put 2,000. Skip one, we'll put 3,000. Skip one, 4,000. Skip one, 5,000. That's the highest I need to go. It looks like the highest I need to go on my temps is about 60. So let's go by 5s every single one, but let's go 10s every other. So that I'm technically still going by 5s, but I just don't have to write as much. Oops, this should be 50. 50 right there. 60, and then we got 70 up here. Now let's graph my ordered pairs. I have 0, 59, so 0, 59 is going to be right about there. 500, 59.2, so that's a little bigger. About right there. 61.3 on 1,000. So just above. 1,500, so the next line is 55.5. 2,000 is 41.6. 2,500 is 29.8. That's a pretty big drop there. 3,000 is 29.9. 3,500 is 18.1, even a bigger drop. 4,000 is 26.2. And then 4,500 is 12.4. Oh, nope, 12.4 would not be above 15. Hold on. That's for 4,500. There we go. and then 5,000 would be at 0.6, so like really close. So if I look here at my data, it looks like it's going downwards, right? So this would be a negative correlation. Now let's look at creating a trend line. So very first thing you gotta do is make a scatter plot of this data. So what's the approximate score if a student studies for 4 hours? So it looks like I need to go by ones on my study. Whoops. Study, and then it looks like we have what's known as a Regent score, which is a kind of test you can take. There we go. So go by 1. Basically every other, I'm going to just write an odd number. There we go. And then it looks like I can go by tens. Every single one. 50, 60, 70, 80, 90, and 100. Fill these in so I can see. There we go. So 3 is 80. 5 is 90. 2 is 75. 6 is 80. 7 is 90. 150. 265. 7 is 85. 1 is 40. And 7 is 100. There we go. So if you kind of look at this data, it looks like it has a positive correlation. So now, how are you going to estimate the score if a student studies for 4 hours? Well, you're going to create what's known as the trend line. The trend line is going to basically be a line that kind of connects all the dots or has enough above and enough below. Here's how you're going to do this. You're first going to draw a circle around the dots that you currently have. So try to make it an oval so it kind of connects almost all of them. Make it a nice tight oval around the edges. Okay. Like that. Now what you're going to want to do is connect a line through enough dots, but now you want to make sure that you have the same number or close to the same number above that line as you have below that line. So I kind of notice if I go like this, that I have 1, 2, 3, 4 down and 4 down, right? If I would technically go through this dot right there. So I can now write this equation of the line I just drew in the middle of my oval. So what I'm going to do is pick these 2 points. I have the point 150 and the other point 7/100. Okay, now what I'm going to do is write the equation like we've been do before. So I'm going to do my slope. So 100 minus 50 over 7 minus 1, which is 50 over 6, which is 25 over 3, right? Well, now let's write the equation using one of these 2 points. I'm going to use translated form, 10 times quicker. So I get y equals 25 over 3, and then it's going to be x minus, let's go 1, plus 50. Now what I can do is plug in a 4 for my x, because that's how many hours we want to know about. So I'll go 25 over 3, 4 minus 1, plus 50. Well, 4 minus 1 is 3, right? And then 25 over 3 times 3 is just 25. So technically I'm going to be left with 25 plus 50, or a Regent score of 75 would be an approximate score if we would assume a student would study for 4 hours long. So about 45 we're saying. Now, the trend line might not be perfect. You might get a different trend line depending if you connected different dots or you drew a different line than I did. That can happen. Now, what you're going to want to make sure is you kind of get a nice trend line. I'm going to show you, we're going to spend an extra day on this, and we're going to show how do you find the best trend line for your data. And we're going to use technology for that. The last thing I want to talk about is what's known as causation versus correlation. So causation means that there is a cause. One thing causes another thing. Correlation means that they both go up. They do not mean the same thing. It's kind of like they say that the sale of ice cream goes up in the summer, but so does this number of drowning deaths. Well, they're not causing each other, right? The number of ice cream purchases does not cause the swimming pools or people drowning. But there's a correlation because they're both happening in the summer. But one does not cause the other. So we need to make sure we know the difference between the two when we're talking about our data. So let's see if we have a correlation, and if there is there a causal relationship, aka does one cause the other? So I have the number of loaves of bread baked and the amount of flour used. Well, there is a correlation. If we think about it, if I bake 5 loaves of bread, I'm going to use quite a bit of flour, right? So there is a positive correlation. There is a positive correlation. Now, is there a causal relationship? AKA, does the number of bread I baked, does that cause the amount of flour to go up? And yes, that is true, right? If you think about for the explanation, if I bake 5 loaves of bread, I'm going to be caused to use more flour. So that would be kind of a good explanation to write. The number of mailboxes and the number of firefighters in a city. So let's think here. If the mailboxes go up, will the number of firefighters go up? Yeah, I would think so, because think about if I have more mailboxes, if I put more mailboxes up, that means more people are moving into a town, right? If more people are moving into a town, that means I probably need more firefighters in my town, right? Or more fire houses to make sure I cover my town equally. So I would say there is a positive correlation. And we kind of talked about that there is a causal relationship as well. Because if I have a lot more mailboxes, that means more people are moving in, which means I probably need more firefighters to help keep my city safe. What about the amount of time I study for a test and the score you receive? Well, we kind of looked at that already. There was a positive correlation, and that is a causal relationship as well. There is a cause. If I study more, most likely I'll get a better grade on my test, right? Now, just like all 3 of these gave me a cause and correlation, not all of them will. So make sure you kind of think and rationalize in your head. Just because they both go up at the same time, does that mean that they're causing each other to happen? Always be careful with that when you're looking at data, or even in the newspaper. Make sure you kind of look and see, is there a causal relationship, or are they just correlated? And that's the end of this video. See you later, Sabers.